Today I will build the circuit from mutualism for the requested assignment. So first I'm going to grab some AC voltage, place it down, set it to 4 volts, leave it at 1000 hertz. Then I'm going to get a second AC voltage and set it to 2 volts at its peak. I'm going to add 3 resistors. These are all going to be set to the values of 1.5K, 2.2K, and then 4.7K. Then I'll grab a capacitor. Should be right here. So this one's going to be 0.1 UF, or nanofarads. And this will be 0.47, 470 nanofarads. 47 nanofarads. Oops. I'm going to get a ground. I'm going to wire these all up. Just wire everything else to ground, and then check the reference image, because it's kind of hard to remember the circuit off the top of your head. And then there you go. You click run. Oh, that's right, you need a voltage. Then you click run, and it should show a peak to peak. Now you can also do transient, which will just kind of simulate that one. Yet again, it shows it peaking at 2.5 and then dipping down to, again, to 2.5. But you can move this guy around to other spots. There's one that did 2 wavelengths. I guess it was just that one time thing. But anyway, if you actually want to build the circuit to test with the waveforms, I don't have the capacitors, but these 2 vertical facing resistors are the capacitors. And 3 resistors in a row. The 1.5K being on the left, the 2.2 in the middle, and the 4.7 on the left. I mean the 1.5K on the right, and then for those values, and then the 2 capacitors, the 100 nanofarad would be on the right, and then the 47 picofarad, 4700 picofarad be on the left. And then you would take the 2 AC waves and you would plug them into the ends of the capacitors. So the 1.5K would have like the plus 4 volts AC switching at 1000 hertz per second, and then the 4.7K resistor would have the 2 volts switching at 1000 kilohertz, and then the voltage reading, obviously, to get the scope. So you set up on waveforms. Set up 2 scopes. This is the 2 volt scope, and this is the 4 volt scope, and they're all plugged in here. Can't run it because I don't have any capacitors. It's probably not gonna do anything. Makes a whining noise. But anyway, what the circuit does is it actually just regulates an AC output. So what happens if I increase the capacity, the capacitor? It should just charge up the capacitor. These aren't really as affected by AC. These capacitors are actually used in voltage multipliers a lot because they kind of let AC pass through them very easily. They don't really apply much resistance, so you can use these to multiply a bunch of voltages together, and I believe this one is just charging the capacitors rapidly. It's just demonstrating that they don't actually have much effect on the AC wavelength. See, for example, if I put the thing here, see the amplitude, you can see the time. Let's say I make this capacitor like 100,000 times stronger. So 100,000 times more resistance. Oh, it does shift it a lot. Maybe that size. Oh, these capacitors, oh, I'm not even on the right mode, that's why. It does shift this. Oh, it shifts the switching cycle time. That's interesting. Oh, this is a timing circuit. So these control the timing of the circuit. That's kind of neat. No, nothing. I'm not entirely sure what's going on with the simulator. It doesn't really seem to be affected by... Oh, it is affected. I'm not sure what these values... Oh, I'm measuring the resistor or the capacitor value. So it does dampen the wave. Oh, it's just dampening the wave. It's kind of weird. Well, this is a pretty cool experiment with the capacitors, and you can change the peak of your wave by modifying the capacitor values. It's pretty cool. I guess the bigger the capacitor, the harder it is for it to switch, which would drop the wave. Yep. It's pretty cool. All right, I'm going to submit this now.